Hello, dear students. Today, let us discuss a new concept. It is very interesting and very useful for us in our daily life. Let us see what it is. Before explaining the concept, let us discuss a small phenomena in our regular life. For example, a bus driver. So there is a bus. Starts from point A and is able to reach point E. Say for example, this is a distance of 100 meters. A bus driver traveling from A to E, which is 100 meters, 100 kilometers apart. Now, from A he starts. And from A to B, he travels with a speed of say 20 km/h. Next, B to C, he travels with a speed of 40 km/h. Next, C to D, he travels with a speed of say 60 km/h. Next, from D to E, he travels with a speed of 20 km/h. So with different speeds he is traveling. Now my question is, what is his speed? What is his speed with which he travels from A to E? Can you give any single answer? No, it's not possible. Because here he travels with different speeds. 20, 40, 60, 20, like that. That's why we can't give a single answer in this problem. If I take one more example, when he is traveling from E to A. For example, now the boy is traveling, the driver is traveling from E to A. During this, he may travel from E to D with a speed of 40 km/h. From D to C, he may travel with 30 km/h. And at B, he may take a rest. C to B, he may travel with a speed of 40 km/h. And at B, he may take rest. Next, from B to A, he may travel with 10 km/h. Now, can you tell me what is his speed when he is traveling from E to A? No. Here also, we can't give a single answer when he is traveling from E to A, because from different stations to different stations, he is traveling with different speeds. That's why we can't give one single answer. In what purpose we use this example? Let me explain now. For example, a person is planning to take journey from A to E. For that, what is the time duration required? So, for example, if you want to reach E at 10 a.m., at what time he has to start at A? That is our question. If I take the speed as 20 km/h, what is my time? Time is equal to distance by speed. So distance is 10 km and speed is how much? 20 km/h. You will get one answer. If I take the time as, if I take the speed as 40 km/h, I will get different answer. If I take 60 km/h, I will get different answer. So that's why I can't take any one single speed in this case. In such cases, what we have to do? We have to take the average speed. We have to take the average speed. Then only we can calculate the, or we can estimate the time at which the bus can reach from point A to E. In general, it is our regular experience that whenever we make our journey through bus, it stops and it starts. Some persons again enters into the bus, some persons leave the bus. So it is a regular process in which the bus can't move with a constant speed. Its speed varies. In such cases, we have to calculate the average speed to estimate the time. Accordingly, we can plan our journey. So today our discussion is to find the average speed. Generally, we have the formula for speed as distance by time. For average speed also, more or less, the formula is same. The formula is for the average speed. The formula is total distance by total time. What is our average speed formula? Total distance covered by the body by total time taken for the journey. So these are standard formula. If you can remember this formula, you can find average speed. Same thing, the formula for average speed is total distance covered by the body or total distance covered by the body divided by total time taken. So these are the standard formula. Remember this. Based on this, we have different cases. Now I would like to discuss all the cases. So let us go to our chapter now. Now let me discuss one case. It is a very standard case and the derivative formula is very important. Try to remember that formula. The question can be asked in two ways. I will explain those two ways. For example, a boy travels from A to C. A boy travels from A to C. He travels first half of the distance with the speed s1 and next half of the distance with the speed s2. Then what is his average speed? That is the question. Note down, a boy travels from A to C, which is separated by distance d. He travels first half of the distance. Say for example from A to B, it is first half of the distance with the speed s1. Next half of the distance with the speed s2. Then what is the average speed in this condition? Use the standard formula. Average speed equal to total distance by total time. So what is the average of total distance? D is our total distance. So average speed is equal to total distance D divides time. What is the time taken? From here to here, we don't know the time at once. Say, from here to here, the time is T1. Next, from here to here, the time is T2. As the speeds are different, times will be obviously different. So here to here it takes T1 time, here to here it takes T2 time. Now our job is to find T1 and T2. As yesterday I have discussed, speed equal to distance by time. Time is equal to how much? Distance by speed. Here for T1, the distance is d by 2 and the speed equal to how much? S1. Similarly, for T2, the distance is d by 2 and the speed is S2. So in this way I got T1 and T2 values. I can substitute those T1 and T2 here and I can get average speed. So average speed equal to distance by time. What is the time? T1 plus T2. That's why d by T1 means how much? D by 2S1 plus T2 means d by 2S2. Upon simplifying, we get 2S1 S2 by S1 plus S2. Have you got it or have you achieved this? This is a simple mathematical calculation. You can do it. I am not interested to solve such mathematical calculations. Being a mathematics student, you can solve this. So it is 2S1 S2 by S1 plus S2. So this is the average speed of the boy when he is traveling from A to C. This question can be asked in another manner also. The same question can be asked in another manner. I'll explain that second type of questioning. Let us see now. For example, a boy starts from A and reaches to some point B with a speed S1 and he returns from A to B. He travels with the speed S1 and he returns with the speed S2. Now the question is, what is his average speed? The answer is same. Can you tell me how? Think. Have you got my question? A boy travels from A to B with the speed S1. Next B to C, B to A means he returns with the same speed, not with the same speed. He returns with the speed S2. Then what is his average speed? The answer will be same. How? See, the entire journey from A to B and B to A, if we take this entire journey as one phenomenon, from A to B can be treated as the first half of his journey. First half of his journey. Next B to A, it can be treated as next half of the journey. Next half of the journey. Means here he is traveling in the straight line, but here he is traveling in the moving to and fro. But the inner meaning is the same. In both the cases we get the same answer. No doubt. Now I am giving you a small homework problem. Do it. A boy travels from A to D, which is separated by a distance of D. Now the distance is divided into three equal parts. The distance is divided into three equal parts. First, 1/3 distance it travels with the speed S1. Next, 1/3 distance with the speed S2. Next, 1/3 distance with the speed S3. Now the question is, what is his average speed? In the earlier problem, the distance was divided into two equal parts. Now it is divided into three equal parts. He travels with the constant speed S1, S2 and S3. Now the question is, what is his average speed? Do it and post the answer to me. I am waiting for your answer. Now, my next question is, in the previous problem, the distance was divided into 2 parts or 3 parts. Now I am dividing the time into 2 parts, the journey time into 2 parts. For example, if it travels for 2 hours, first half 1 hour with the speed S1, next 1 hour with the speed S2, then what is his average speed? That's my question. So now let us see how to solve such problems. For example, a boy is traveling from A to some C. The journey time is T. Now he travels the first half of the time with the speed S1. Next half of the time, maybe he took more time. Sorry, he saved time, but the speed is increased. Speed may be increased. That's why it appears to be more distant. So with the speed S2, first half of the time with the speed S1, next half of the time with the speed S2. Now the question is, what is his average speed? Problem seems to be different. In the earlier problem he divided the distance, here he divided time. But the question is, what is his average speed? My formula is same, total distance by total time. So average speed equal to total distance by total time. In this problem, did he give the distance? No. He spoke about the time and the speeds. He didn't mention the distance. That's why let it be D by total time taken. What is the total time taken? T. Distance is not given. But from our previous formula, is it possible to find the distance? Yes. D equal to S into T. Means D1 equal to S1 into D1. D2 equal to S2 into D2. So D1 is equal to, means can I imagine this distance as D1? This as D2. Then D equal to D1 plus D2. What is my D1? S1, speed is S1 into time is T by 2. Similarly, what about my D2? S2 is speed S2 into T2 means here time is T by 2. Got it? Now if I can substitute this D1 and D2 here, what I get? Average speed equal to S1 into T by 2 plus S2 into T by 2 by T. Upon simplification, T gets cancelled. This will be left with S1 plus S2 by 2. This is the formula in this case. Have you got it? In the first case, he divided the time into distance into 2 parts. Now he divided time into 2 parts. Whatever it is, formula is standard total distance by total time. So by using that, you will get this. In some more problems, he may try to complicate the problem and he may divide the distance into 2 parts and also time into 2 parts. In such case,